Alright, so today we're talking about graphing square roots and cube roots. So, starting with the parent functions. My first function that we're going to look at is f of x, which is the same as y, is equal to the square root of x. So let's make our table. Now, normally when we make our table, we start with the x's and do the -2, -1, 0, 1, and 2. But if I put in -2 there for the square root of x, can I do that and get a real number?
No.
No. So, let's kind of think backwards here for a moment. So, square root of x, what is the opposite operation of square rooting? Squaring. If you remember, instead of opposite operation, it's the inverse. Also, if you think back inverse, we would switch the x and y's. So what I'm actually going to do, we're going to work backwards. I'm going to start with the y's first. And I'm going to start with actually 0. So 0, 1, 2, 3, and 4. Now, since we're reversing, starting with the y's to get the x's, my equation would be square rooting the x's to get the y. So reverse would be taking the y's, squaring them to get the x's. So what is 0 squared?
0.
And 1 squared?
1.
And 2 squared?
4.
3 squared?
9.
And 16. So this is your parent table for square root of x. So let's go ahead and graph this. Yes.
For the y's, wouldn't it be positive and -2? Because 4, no.
No, just the
What you laughing at?
just the positive of it. So going back to thinking about the inverse. So if I graph the inverse of this equation, so y is equal to x squared, it is a parabola, that U-shaped graph. Well, if I took that parabola, switch the x and y's, which is what I did, and we put it this way, if I had that whole parabola, it would not make a function. So that also kind of why, if you think about it, it wouldn't make a function if I had both points.
Oh, okay.
So only this part, which makes it a function.
Thank you.
You're welcome. Alright, domain and range. So remember, domain is your x. My least x is 0. We're using 0, so bracket. And the arrow goes all the way out, so 0 to infinity. And then my range, 0 to infinity as well. Alright, next, f of x is equal to x cubed. We've already done this in previous units. For this one, we're going to start with a -2, -1, 0, 1, and 2. So -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1, and 2 cubed is 8.
So we only do the 1, 2, 3, 4 thing on the cube.
Yes.
On the square root one?
Yes.
Okay. Thank you.
Alright, now let's graph these. then for this one, where the main and range is negative infinity to infinity for both of them. Remember, infinity uses the parentheses, not the bracket. Alright, go on with the same thing of thinking about inverse. So, the inverse of cubed root is, the inverse of cubing is the cubed root. So, to make this table, it is just the parent function, so inverse we flip the x and y, so we're just going to flip this table. So your y's are going to become your x, so negative 8, negative 1, 0, 1, and 8. And then negative 2, negative 1, 0, 1, and 2. Nope, it's just flipped.
Wait, so you're able to find the cube root of a negative?
Yes.
Oh, okay, so you're just not able to find the square root of it?
Correct. Because, so square root, when you take the square root, you're looking for two factors that are the same. So square root of a negative number, in order to get a negative number, it has to be one positive, one negative for two factors. But for the cubed root of a negative, you can have three negatives. Negative times a negative is positive, times another negative is a negative. So for the odd roots it works, but not for even roots. Alright, so your domain and range here would be the same thing as what is above. So negative infinity to infinity for both. Any questions? Alright. Next, graphing. Shh. For graphing, first one, y is equal to the square root of 1/2 x plus 2 minus 3. So, I know I usually say anything where I have said, but inside the parentheses is your x. Anything underneath your radical deals with your x. So if I look here, square root of 1/2 x plus 2. We're graphing the same way as how we have been for every other function. The only difference is the function changes, so that initial table. With the 1/2 x plus 2, we have to factor out the 1/2. So remember, whatever a, or is the value of b is not 1, we have to factor it out. So a half of what would equal to a positive 2? 4. So this is square root of 1/2, and then parentheses x plus 4, and then minus 3 at the end. Alright, I know there's not a totally in a squeeze one table over here. So, parent function table for the square root of x. The x is 0, 1, 4, 9, 16. And then y is 0, 1, 2, 3, and 4. Alright, now, ready for the transformation. Anything in the square root deals with the x. Remember, x is y, it's the opposite. So instead of multiplying by 1/2, we really need to multiply by 2, and instead of adding 4, we need to subtract 4. Also remember, don't use the unfactored form. After you factor out, you're using the factored form. Factored form. And then for your y's, everything outside, we're not multiplying by anything, but I am subtracting 3, so y minus 3. Now let's figure out your x and y. So if I put in 0, 2 times 0 is 0, minus 4 is negative 4. 2 times 1 is 2, minus 4 is negative 2. Plug in 4, 2 times 4 is 8, minus 4 is 4. Then 9, 2 times 9 is 18. 18 minus 4 is 14. And then for 16, 2 times 16 is 32. Minus 4 is 28. Now for the y's, we're just going to take each of these and subtract 3. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. Then we have negative 1, 0, and 1. And now we can graph these ordered pairs. And the 14, 0, and 28, 1 is off the graph. So this is what your graph looks like. Now for the domain, so we shifted it to the left 4 units. So we're starting at negative 4, so bracket negative 4 to infinity. And for the range, we shifted it down 3 units. So we're going to start bracket negative 3 to infinity. So my parent function, it would be 0, infinity, to 0 to infinity. What is, remember the anchor point? What is the anchor point of this equation? Negative 4, negative 3. Look how that matches your x and y. Yeah, we'll talk about that more in a little bit again. Yes?
Why did you make it 2x minus 4?
Because anything with the x lies, it's the opposite. So a half is opposite is 2. Opposite of adding 4 would be subtracting 4.
Okay.
All right.
When you're multiplying by, what if it was like a 2 in front? Then it would be you're doing it by 1/2?
Correct.
Okay.
And remember, very common mistake I see here is that y'all will put 2x minus 2 because you're using this one. No, factor out and don't use this one anymore. Use the factored one. Alright, next one, y is equal to 3 square root of x minus 2 plus 1. So again, we have square root. So same parent function table, 0, 1, 4, 9, 16 for the x's. And for the y, 0, 1, 2, 3, 4. Now if we look underneath the radical, we have x minus 2. That b value that we're multiplying x is 1, so nothing to factor out. So this is just x. Opposite of minus 2 is plus 2.
That's 3y plus 1.
Yes, and then for the y, everything on the outside, so we're multiplying by 3 here, so 3y, and then we have the plus 1. Remember, you don't flip anything with the y's, only the x. So let's find any other pairs, and I put in 0, 0 plus 2 is 2. Then put in 1, 1 plus 2 is 3. Then I put in 4, 4 plus 2 is 6. Then 9 plus 2 is 11. And 16 plus 2 is 18.
Why is, I don't get why the X lies.
It's just the rule.
So when do you have it? So what's the case?
Now for the y values, so we have 3y plus 1, so when I put in 0, 3 times 0 is 0 plus 1 is 1. Then when I put in 1, 3 times 1 is 3 plus 1 is 4. And then 2, 3 times 2 is 6, plus 1 is 7, and then we have 10 and 13. And so now we can graph. Alright, so that's what my graph looks like. So my new domain, my least x value is that positive 2, so 2 to infinity. And in my range, my least y value now is positive 1, so 1 to infinity.
And the anchor point is 2 left.
Yeah, so your anchor point here is 2, 1.
Record points just whenever 0 turns into red, whenever 0, 0.
Because it says, you know, right on.
Yes.
Since it's like a negative, it would be a positive.
Alright, let's look at the next two.
There's a stupid.
Yes, shh. Next one, y is equal to 1/2 times, in parentheses, x plus 3, and then all of that in parentheses, to the 1/3 power plus 1. Your 1/3 power is the exact same thing as the cubed root. So this is the same thing as the cubed root of 1/2 x plus 3, and then plus 1. So, cubed root. And with the 3 right there. So it's the same exact thing. Alright, now, parent function table. So this would be the -8, -1, 0, 1, and 8. And for the y is -2, -1, 0, 1, and 2. Now for the x's, the 1/2 is already factored out. So the opposite of multiplying by 1/2 would be multiplying by 2. So 2.
Minus 3.
Oh, yeah.
Perfect.
Yeah, yeah.
Yeah.
And what would the y values be?
I plus 1.
Y plus 1.
Okay.
Alright guys, shh. Now I'm going to plug in these x values. 2 times -8. -16 minus 3 is -19. Now I'm going to plug in -1. 2 times -1 is -2 minus 3. Then 0 is -3. Then 1, 2 times 1 is 2. Minus 3 is -1.
What was that?
Sure, that's what I thought.
That's what you thought.
Alright, now for the y's, we're going to add 1. So -2 plus 1 is -1, and then 0, 1,
2 and 3.
2, and 3. Now we're going to graph. negative x to negative 1 is off the graph. Now negative 5, 0. Negative 3, 1. Negative 1, 2. And 13, 3 is off the graph. So it looks like that. So domain and range,
Infinity, infinity.
yeah, negative infinity to infinity for both.
Oh, wait, is there an anchor point for those?
Yes, your anchor point will be the negative 3, 1. Alright, next one for the graphing. Y is equal to negative 2 cubed root of x minus 3 plus 1. Same cubed root, so same parent function. I messed that up, 0, 1, and 8. Alright, now if I look here, inside with the x minus 3, nothing to factor out, so this would just be x plus 3. And then for the y is everything on the outside, so I have a negative 2, y, and then plus 1. So y, I'd figure out your new x and y values. And plot your points. Your domain is still the negative infinity to positive infinity for domain and range. Now writing the equations first. Yes.
And I have a question. For the domain and range, if we both have negative infinity and infinity, what AQ will we have?
You still would have 3, 1.
Oh,
Which your anchor point is still around the 0, 0, which is still here like the h and k, which is 3, 1.
oh, I see.
Alright, writing the equation for the square root function. So your equation, it's going to look like y is equal to a square root of x minus h plus k. Same exact way that we've done every single other time that we have written equations from the graphs. Just different, like, parent function. First thing, we always had to solve for a. So I need my anchor point, which is your hk, and we need another point to plug in for x and y. So your anchor point here, it's right here, at 1, 2. And the point that I'm going to use is right here at 2, 5. So we're gonna plug in the point in for x and y and the anchor point in for h and k. So y value of the point is 5 is equal to a square root of x value of the point is 2, minus x value of the anchor point is 1, and then plus y value k, y value of the anchor point is 2. So 5 is equal to a, 2 minus 1 is 1, so square root of 1 plus 2, yes.
So the anchor point is like the one it takes off from, right?
Yeah.
Like the one on like the very bottom? Then how come for the third one, you said the anchor point was -3.
Because your anchor point is your HK. So your HK for over here would be the -4, -3.
Okay.
So it's basically the anchor point, the original anchor point of the parent function is 0, 0. And it's basically the transformations to that of how are we moving up, down, left, or right.
Okay, thank you.
You're welcome. All right, so continuing over here, 5 is equal to square root of 1 is 1. So 5 is equal to a plus 2. So a is 3. So your equation then is y is equal to, so a is 3, square root of x, h is 1, so x minus 1 plus 2.
Oh, so the plus 2 is like outside of the square root?
Yes.
Guys, let's be quiet, please.
Oh, sorry.
We good for that one?
Yes.
Alright, next one. Now we're going to write the equation of the cube root function. So this one is going to be y is equal to a, the cubed root of x minus h, and then plus the k. So our anchor point, your anchor point is the one right here. So that is -3, -1. And we need another point. It doesn't matter which point you use. I'm going to use this x-intercept because I like to use where x or y is 0 when I can. So this will be -4, 0. So plugging into the equation, y value of the point is 0 is equal to a, then the cubed root of x value of the point is -4, minus h, x value of the anchor point is -3, so this becomes a plus 3, and then minus 1. So 0 is equal to a cubed root -4 plus 3 is -1, minus 1. The cubed root of -1 is just
-1.
-1. So this is -a minus 1. So to solve for a, I'm going to just add a to this side to move it positive. So a is equal to -1. So your equation, y is equal to negative cubed root x plus 3 minus 1. Last little bit. We're going to be just talking about domain and range. State the domain and range and interval notation for the following equations. So, number 1, f of x is equal to square root of x minus 4 plus 6. What would my anchor point be?
4, 6.
For 6. So this is the square root if we just kind of think about it graphically, so 4, 6, and then it would go like that. You do not have to sketch a graph. If you just visually need one, you can to look to see. Alright, so domain. So domain here is from 4 to infinity. And your range, 6 to infinity. So basically, you're taking the parent function and you're applying the transformations. Yes,
You know, like it was pointing that way on the graph.
because that's how the parent function is like this.
Oh, yeah.
So all I did was move it to the right form, yes.
Oh, okay.
Oh, we see it?
Yeah.
And if we multiply by anything here or here, it would still, that anchor point would still be here, so it doesn't matter how far up or, it's still same domain and range. The only other thing that would affect it would be whether we have a negative or not, because that is a reflection. So if you look at number 2, we have a negative on the outside here. So first, before we do that, let's actually give our anchor point. So what's my anchor point?
-1, -2.
-1, -2. Now I have this negative on the outside. Negative is a reflection. This one is over the x-axis. So what it actually affects is the range. Because if here's the x-axis, we're flipping from here over to here. No, wrong way. X-axis from here down to here. So those y values are changing, which should be what's changing because it's on the outside affects the y. Y is range. So domain. So we're still using that anchor point. Actually, the anchor point is -1. So -1 to infinity. And the range, actually that's kind of graph this. So my anchor point is at -1, -2 here. So if you think about the parent function, so it would be this way, then we would be reflecting over the x-axis, so then it would be going that way, but then we're shifting it, so it's going to look something like that. So your domain is still the same, your range just flips, so it's going to be from -infinity to -2 bracket. Any questions? Alright, number 3. Square root of negative x plus 1 and then plus 3. So what is my anchor point?
-1, 3.
-1, 3. We have a negative. This time it is on the inside or underneath the radical. So this is a reflection
Over y.
over the y-axis. Which affects your domain. So thinking about this graphically, my parent function like this, we're reflecting over the y-axis, so it's gonna then look like, go that way. My anchor point though is at negative 1, 3, so we need to move those down, or over to negative 1, up 3. So it's gonna go like that. So my domain, it's now from negative infinity to negative 1 bracket. And your range is from 3 to infinity. So you're using that anchor point. It doesn't matter whether you're multiplying by the x or y, that's not going to change your domain and range. The only other thing that would change it would be the reflection. If it affects the y values, you flip the range, but use negative infinity. If it affects the x, flip the domain, but with a negative infinity instead of the positive. Next, we're going to state the domain and range in interval notation for the following rational equation. So, steps. First step, factor, cancel if possible. Then, we're going to start with the domain of negative infinity to infinity, and we're going to remove the whole and the vertical asymptotes. And then for the range, we're going to start with the range of negative infinity to infinity, and remove the whole and the horizontal asymptote. So if I look at my first one, nothing to factor, nothing to cancel, so there is no whole. Vertical asymptotes. We're looking at the denominator. So this would be x is equal to 2. Horizontal asymptote. So x over x, y is equal to 1, exponents are the same, divide the coefficients, 1 over 1 is 1. Now for my domain. Remember we're starting from negative infinity to infinity. I just can't use 2. So this is going to be from negative infinity to 2, parentheses with 2, because asymptote, we're not actually going to get to 2, and then u, 2 to infinity. Same thing with the range, we're just using the horizontal asymptote. So negative infinity to 1. And then the year on 1 to positive infinity. Any questions? Alright, 5. X squared plus 4x minus 21 over x squared minus x minus 6. So we're going to need to see if we can factor. Yes, x minus 3. X plus 7. The only factors in 21 are 3 and 7. Or 1 and 21. And for the bottom,
X minus 3x plus 2.
x minus 3, x plus 2. So we share x minus 3. So a simplified equation here would be x plus 7 over x plus 2. This time there is a whole at an x value of 3. Yes. So if I figure out, use the simplified equation, 3 plus 7 is 10. 3 plus 2 is 5. So 10 over 5 is 2. Do I have a vertical asymptote?
Yes.
Yes. X equals negative 2. And horizontal asymptotal heaven?
No, it's white with order.
Yes. Alright, this time, we do have to also think about with the whole. So domain, we're still going to say negative infinity. So if you look at your axis, so we're talking about the 3 and the negative 2. Where negative 2, the number line, comes before 3. So it's going to be negative infinity to negative 2. Then we're going to pick it back up. So negative 2 to 3. And U 3 to infinity.
Is it always gonna start with negative infinity to?
Yes.
Okay.
Then your range. Your range, so with the negative infinity. So we've got 2 and 1. So negative infinity to 1. 1 to 2. 2 to infinity. Yes. Alright, if that's still kind of confusing, my suggestion, if you need more of a visual, think about like a number line. So here's my domain. We have a hole where x is 3. So this is going to be at 3. I have a vertical asymptote at negative 2. So negative infinity to negative 2. Then we pick it back up from 2 to 3. And then pick it back up from 3 to infinity. Any questions? Alright, last one. Finding the domain for rational equations written with radicals. So start with the domain of the numerator. So we're just looking at square root of x plus 3. It's like what we just did on this side. So square root of x plus 3. You can even think about this graphically if you need to. So your function, your anchor point here would be the negative 3, 0. So it would look like that. So this would be bracket negative 3 to infinity. Step 2 then says continue using the restriction from the denominator to finish writing the domain. So x plus 2 here, my restriction, x cannot be equal to negative 2. Now I have to write my domain, this with that. So bracket negative 3, then we come to negative 2. Parentheses, because we cannot use it. Then you pick it back up at negative 2 parentheses to infinity. Even if you think about it graphically, here negative 2, there would be a hole there.
And you don't have a line.
Why are we using,
You do not have to find range.
why are we using parentheses?
Negative
2 bracket.